All right, I'm back, folks, with video 9, basic trig word problems. I know that you love these just as much as I do. Who doesn't love a good word problem, you know? All right, let's get started. So you're going to see some words in these word problems that say the angle of elevation is, or the angle of depression is. You need to be able to draw that picture before you even solve the trig problem. So to do that, I always recommend drawing a Z. Now notice that when we have a Z here, that this is parallel to that, if you think back to geometry. And we also have alternate interior angles right here, also thinking back to geometry. And what you should know is that your angle of depression is always going to be the same as your angle of elevation. So if you're in an airplane right here looking down at this huge guy or girl, whatever they are, you look down at them at 40 degrees, and they actually look up at you at 40 degrees, which is kind of cool. Okay, again, I always recommend drawing this Z when you're doing angle of depression or angle of elevation problems. If you get confused with where to put your angle of depression, just rewrite the problem as angle of elevation, and you're more likely to get it correct. All right, the other situation that we might have is this one right here. We might be talking about a car driving on a road, and the road drops at a grade of, and that angle would go right here. It's kind of like the angle of depression. And then it makes more sense, I think, to say that it increases at a grade of here. But just remember, those two things are the same. Of course, if the road drops at 5 degrees, it's going to also increase at a grade of 5 degrees as well. Increase. Okay? All right, let's go ahead and let's get started on these problems. All right, the largest escalator in the United States is 200 feet long, the distance people actually travel, and has an angle of elevation of 25.15 degrees. How high is the top of the escalator above the ground floor? Well, what did I say to start with? You said Z, you are correct. So here we are. Our escalator would probably be this. It's a little steeper than it probably is, but that's all right. Let's go ahead and label things. We've got an angle of elevation of 25.15. That goes right here. And we are also told that the escalator is 200 feet long. So this red part here is 200 feet. And then I'm just going to close off my triangle here. Of course, it's a right triangle. And I want to know how high the top of the escalator is above the ground floor. Well, where's the ground floor? It's obviously right here. So that height is going to be right here. That's going to be our x, our missing variable. All right, let's solve this. So we're going to circle this angle right here, go across. This is my opposite. Okay, go across from my 90. This will be my hypotenuse. And I don't even need to bother with this side, my adjacent, because my x and my number are already labeled. All right, so what are we going to use here? Opposite and hypotenuse. Sine is correct. It's going to be sine of 25.15 is equal to x opposite over my 200. Okay, then I need to multiply by 200 on both sides. Here the 200s cancel, and I'm left with an x equals, and that's just going to be 200 sine of 25.15. All right, and I'm going to do that real quickly. And I get 85. It's 84.99, but let's just say x equals 85. And we do need to go back and make sure our units are proper. So we've got feet here, so I need to go ahead and say that we have 85 feet. So that means our 200-foot escalator actually rises about 85 feet. That seems reasonable. All right. In Sichuan, China, Bernarda stands at the top of Jingping 1 Dam and measures the angle of depression down to where Benjamin is standing at 2,000 feet from the base of the dam. If the angle of depression is 26.6 degrees, how tall is the dam? Well, let's go ahead and make the dam here. D-A-M. Let me write that better. There's our dam. And so we have Bernarda standing at the top. So they would be right here. This is Bernarda. And they see Benjamin down here. Now, you're really tempted to put your angle of depression here. But what letter did I ask you to write at the very start of this? That's right, a Z. So if we draw this Z here, you can see that actually our angle of depression is on the outside. So our angle of depression would be 26.6 degrees right here. And remember, I always say you can change the word depression to elevation. And if you want, you could actually put the 26.6 right in here because depression and elevation are the same thing. But let's keep it there just for the sake of doing that. Let's also mark the fact that Benjamin is standing 2,000 feet from the base of the dam. Well, the base means the bottom. That's what base means. So here's Benjamin. He's looking good. And he is 2,000 feet from the base of the dam. And the question is, how tall is the dam? So that's going to be an X right here. Now I know that this is a right angle, but I also need an angle in this triangle, and I could either put the 26.6 right here, or you could do 90. See, this is a 90-degree angle right here. 90 minus 26.6, and that gives us a 63.4 right here. All right, so really, what are we looking at for our triangle? We're looking at something like this. We've got our 63.4. We've got our X, and we have our 2,000. All right, let's go ahead and label our sides now that we have the picture set up. I'm going to circle this. This is going to be my opposite. Across from my 90 is my hypotenuse, and the remaining side is my adjacent. So which one don't I care about? Well, I care about the A because there's an X next to it. I care about the 2,000, but I don't care about hypotenuse. So OA is going to be tangent. So this is going to be tangent of 63.4 is equal to my opposite, which is 2,000 over X. Okay, now I'm going to multiply by X on both sides. That gives me X tangent of 63.4 is equal to simply, the X's cancel here, 2,000. Now I've got X times something. I want to get rid of that thing that's connected to the X, so I'm going to divide by tangent of 63.4. So the tangents cancel here, and I'm left with X equals 2,000 divided by tangent of 63.4. And I plug that into my calculator, and I roughly get 1,001.5 feet. Maybe check with your calculator that you're getting that answer as well. All right, does that make sense that our dam would be 1,000 feet? Yeah, I think that definitely makes sense. All right, let's take a look at example 3. So example 3 says a straight stretch of mountain highway drops at a grade of 3 degrees. If you drive a distance of 15 miles on that road, how far do you descend vertically in miles? What letter do we write? A Z. So our mountain highway is this right here. Okay, and it drops, do that again, it drops at 3 degrees. Well, you can really think of that if you want as angle of depression, and you can go ahead and you can put that 3 degrees right here. And you could also say that that 3 degrees is here if you'd like, but you don't have to. All right, so what else can we mark in this picture? We can mark that if you drive a distance of 15 miles on this road. So we're going to say that this is 15 miles. And we want to know how far you descend vertically. How far do you go down the road? Well, we can put this right here because that would be how far you're dropping. Okay, and this is going to be our x here. Well, again, we know this is a right angle, but we don't have any angles in our triangle. We'd have to do some subtraction here and realize that this is 90 degrees. So 90 minus 3 gives me 87 degrees here. All right, so just real quickly redrawing this triangle, just to keep it neat, I've got an 87, a 15, and an x. All right, labeling all my sides. Across from my angle of 87 is my opposite. Across from my 90 is my hypotenuse, and the remaining is my adjacent. What don't I care about? I do not care about my opposite, so I have adjacent hypotenuse, which is going to be cosine. So this is going to give me cosine of 87 equals my x adjacent over 15. Next step here is going to be to multiply by 15 on both sides. And the 15s cancel. I'm left with x equals. I do the top there in my calculator, and I roughly get 0.785, which I'm going to round to 0.79 miles. And does that make sense that you drop a little bit less than a mile? Yeah, sure, that certainly does. So there's our answer. You descend 0.79 miles. Now, I'd like to keep it positive because distance is always positive, but you are going down that much. All right, example 4. And this is our, looks like our last one that we're going to do mathematically, and then I want to look at some pictures just so we know we can set these up correctly. All right, a straight stretch of mountain highway increases at a grade of 6 degrees. Let's draw our z. So we're increasing at 6 degrees. If you drive 10 miles on this road, how far have you traveled up vertically in miles? Well, we still care about this distance right here, so that's going to be our x. All right, this one we don't have to find that angle because it's already set up beautifully for us. So this is going to be my opposite, and this is going to be my hypotenuse. All right, so we have O and H, which is going to give us sine. So we have sine of 6 degrees equals my opposite, which is x over 10. Go ahead and multiply by 10. And we get 10 sine 6 equals, well, here our 10's cancel, x. Plug that in our calculator, 10 times sine 6, and I get 1.045, which I'm going to round to basically saying that this is 1.05 miles. There we go. All right, we're not going to solve these, but we are going to draw a picture for each. Keith looks up and sees a bird. Where's Keith? Let's give him a nice cool LA hat, you know. Let's see, it's on backwards too. LA. Here we are. And then we could even put a Steelers shirt on him. We won't though. He looks up and he sees a bird at an angle of elevation of 5 degrees. I do want to draw my Z in there. It makes me happy. So I'm looking up, or Keith is looking up at 5 degrees. That's our angle of elevation. The bird is 10 meters up in the air. So here's our bird. It's 10 meters up in the air. How far is he to the bird? Well, we're always going to talk about the shortest distance when I'm saying how far is someone from something, so our x is going to be here. That's the setup for this problem. You don't have to do more than that here, but you can solve for that if you'd like. All right, here we go. Next problem, we've got Grant up in a tree. That seems like a reasonable spot for him. So we're going to mark a tree. And hey, why not go a little colorful here, get a nice little bush going on up there. All right, and then we'll have Grant chilling right here. I'm gonna just call him G Money, which I think we should make that a thing. All right, so G Money is right there. I'm gonna draw my Z from G Money. Okay, and we've got a right angle here. So Grant is 6 meters in the air, so I can go ahead and put a 6 meters right here. That's that vertical distance right here. And he looks down and he sees Rex jogging at an angle of depression of 14. Well, here's Rex. We'll call him our dog. Rex is right here, and Grant sees him at an angle of depression of 14 degrees, so we would put that here. And we want to know how far Rex is from the tree, or our dog from the tree. So that's our X right here. That's that distance from our dog to the tree, right? All right, so is this set up to solve? No, it's not. You've got two options here. You could either set this to be 14 degrees, because we know our angle of elevation is the same thing as depression, or we could go ahead, subtract from 90, and realize that 90 minus 14 is 76 degrees. Now we're set up to solve that problem. All right, next picture here. A straight stretch of mountain highway increases at a grade of 4 degrees. If you've risen 1.5 miles, how far have you driven on this road? Okay, here we are. We have a 4-degree increase, so I'm going to put that right here. I've risen 1.5 miles. That's how much I've gone up, so that would be 1.5 miles here. And then we're going to look for how far have you driven on this road. Our X will be right here. All right, a straight stretch of mountain highway drops 1.9 miles after driving 7 miles on this road. What's the grade of the road? How much does it drop in degrees? This is slightly different. We're solving for an angle now, but really the setup is just the same. So we clearly drop 1.9 miles, so that's a 1.9, and we drive 7 miles on this road. And we want to know how much it drops. Well, that would be this angle right here, which is the same as this angle right here. So I can go ahead and erase this. I think that doesn't help us much at all. So that's the setup. And remember, if you're looking for an angle, you really should be doing inverse trig. So if I wanted to solve this problem, I'd circle this angle. This would be my opposite. And across from the 90 is my hypotenuse. And this would be sine inverse, right? Because I have opposite and hypotenuse. So my angle, X, is going to be equal to sine inverse of my opposite, which is 1.9, divided by my hypotenuse of 7. And you just plug that in, make sure you do second sine. Let me get the answer for fun. And I get about 15.74 degrees. Pretty steep road. Not impossible. Guess that should have been 15.75. I'll change that. All right. That's it for video 9. Really having fun talking to myself in a room all by myself. Hope you guys are enjoying and staying safe out there. Can't wait to do video 10. Bye, guys.